right, now we're going to be getting into the good stuff. We are in Chapter 2, Linear Equations. This is still a review from Algebra 1, but I know it's been a while since we saw this stuff, so bear with me. You might still be feeling like this is a review and you already know this, but it's a nice review. So in linear equations, we're going to start with just determining if these values are solutions to the equation or not. What we're going to do for these notes is I'm going to complete the first problem, and after I complete the first problem for you, I'm going to want you to stop the video and complete the second two problems, and then start the video again for an example of the next one. So for the first one, we are trying to figure out if x equals negative 1 is a solution to the equation 5x plus 9 equals 4, and if x equals 2 is a solution. So what we do is we substitute the variable in. So in this case, it's negative 1. We substitute in for x and see if it works for the first one or for the second one. So let's substitute and evaluate. So 5 times negative 1 is negative 5. And negative 5 plus 9 is 4. So because 4 equals 4 is a true statement, then that would mean that yes, negative 1 is a solution to the equation. Let's see if 2 is a solution to the equation. 5 times 2 is 10. And 10 plus 9 is 19. 19 does not equal 4, so x equals 2 is not a solution to the equation. So what I want you to do now is pause the video, try B and C, and then start the video when you're ready for the next example. Okay, in example 2, let me erase all of this stuff. In example 2, we have here solve each equation and then check your answer. Show your work in your notebook. The goal is to isolate the variable. In some cases, you will need to remove the grouping symbols first. So in example 2, we're basically solving these equations for x, and all of these are different. So for the first one, we have variables on both sides. I see 24 minus 2x equals negative 2x. To solve this, what I am going to do is move these variables all to one side. I can either take this negative 2x and move it to the other side by adding 2x, or I can take this one, which is actually the same exact thing, and move it to the other side. Now, this is a little interesting because when this happens, and I add 2x to this side, I'm left with 24 equals, and then when I add 2x to this side, I'm left with 0. Now, this is an interesting problem because when this happens, I'm getting a false answer. That means that this has no solution. In the next one, letter B, below it, the first thing that I like to do is get rid of the parentheses by using the distributive property. So I'm going to multiply 6 times x and 6 times 2. And I get 6x plus 12 equals 30. The next thing I like to do when I'm solving equations is get rid of any of the addition or subtraction, because this equation says 6 times what number plus 12 equals 30. Well, let's get rid of that plus 12 part so we can just figure out 6 times what number is equal to whatever number is on the right. So I'm going to subtract 12 from both sides. When I do that, I'm left with 6x on the left, and 30 minus 12 is 18. The last thing I'm going to do to solve this equation, 6 times what number is 18, some of you will be able to do this in your head at this point, but you would solve it by dividing both sides by 6. And 18 divided by 6 is 3, so we get 3 as our answer. To verify that your answer is true, you can replace the number back in for x and verify that it does equal 30. So what I mean by that is replace 3 in for x. So it would be 6 parentheses 3 plus 2 equals 30. Now, once we replace the number in, we can use the order of operations and not have to distribute. So we can do 3 plus 2 first and get 5. And then 6 times 5 is 30. Or you can distribute 6 times 3 is 18, 6 times 2 is 12, and 18 plus 12 is 30. Both will work. Looking at C, I'm going to do this one and have you guys try D on your own. C has variables on both sides. So I have 9y plus 4 equals 12y minus 2. So because we have variables on both sides, we have the option to move either the 9y or the 12y. If possible, I like to have a positive number of variables left over when I do this. So I'm going to take this 9y and move it to the right-hand side of the equal sign by subtracting 9y. So you do the opposite of what's happening. Because it's a positive 9y, I'm going to subtract 9y to move it. When I do that, these cancel out. I'm left with 4 is equal to 12y minus 9y is 3y, and then minus 2. Now the variable's on the right side of the equation. I prefer to have it on the left side, but I'm just going to deal with it and put my final answer with the variable first later. Now I see where my y is. It's on the right side of the equal sign. That means that I need to move this negative 2 here. To do that, I'm going to do the opposite of minusing 2, which is adding 2. I'm left with 4 plus 2 is equal to 6 on the left-hand side. 3y is on the right-hand side only because these cancel out. So I have 6 is equal to 3y. I'm going to write that over here. The last thing I need to do is the opposite of what's happening with the variable. 3 is being multiplied with y. So I need to undo multiplication by division, and this is how you should be showing your work. 6 divided by 3 is 2, so I get 2 is equal to y, or y equals 2. And again, we could be taking these answers, replacing them in for the variable to verify that it's true. At this point, I want you to pause the video and try letter D on your own. If we scroll down and we try the next example together, in example 3, we have solving equations and fractions with fractions and decimals. So we're going to do a couple of these together, and I'm going to have you guys try a couple. The first one we're going to do together is letter A. So we have fractions here. As soon as you see this problem, you're probably like, oh no, I don't like this. I don't feel like doing a problem with fractions, and I get it. What we have is 11x over 6 plus 1/3 equals 2x. Well, here's the deal. When you have fractions, we can get rid of fractions immediately. All you need to do is take the entire equation and multiply it by a number, and you'll multiply each little term in that equation by that number, and then that special number will cancel all the fractions out, and then you don't have to deal with it. Here's what you will have to do, though. That special number is considered the LCD. That's the least common denominator. It's like the least common multiple of the little denominators of the fractions. So you're looking here at the denominators of the fractions 6 and 3. You need to find the least common multiple between those numbers. That means what is the smallest multiple? It doesn't have to be the smallest. It's really just any multiple that is a multiple of 6 and a multiple of 3. So what you can do here for that is look at the multiples of 6 and the multiples of 3. Multiples are starting at that number, like 6, and then adding itself to it. So the multiples of 6 are 6, 12, 18, and so on. The multiples of 3 are 3, 6, 9, and so on. The first one that you say that is a multiple of both is considered the least common multiple. Well, 6 is a multiple of 6 and a multiple of 3. So what I can do is I can take the entire equation and I can multiply it all by 6, everything. I'm going to take everything and multiply it by 6. And when I do that, it will cancel out all of the fractions. The fractions will go away and they will become integers. And when I have all integers, it's easier to solve. So here's the deal. When you're multiplying everything by 6, you have 11x over 6 all times 6. Well, what's going to happen with the first one is the 6 and this 6 and the denominator are going to cancel out. So you can either understand that, or you can multiply it all by 6 over 1. And 11x times 6 is 66x. 66x divided by 6 is just going to end up being 11x. So when you multiply this all by 6, the 6's end up canceling out, and you're just going to be left with 11x when it's simplified. Next, when you multiply 6 times 1/3, you can use your calculator, 6 times 1/3, and you're going to just get 2. So that ends up simplifying to just 2, which is great. No more fractions. And then you can't forget to multiply everything. So you also have to multiply the 2x by 6, and 6 times 2x is 12x. Now I have this equation, which is a lot simpler to solve because I don't have any fractions to deal with. What I'm going to do is move the variables around so I have all of the variables on one side. I'm going to choose to subtract 11x because I don't want to have to deal with any negative variables. I'll then be left with 2 is equal to 1x, since 12x minus 11x is just 1x, so that I get the final answer is just 2. Okay, letter B is pretty similar to that one, and the next one that's a little bit different is the letter C, the decimals version. So when you have decimals, I feel like it's not as tricky as having fractions. Like, I don't take decimal problems and get rid of the decimals. I just deal with them. So letter C, I'm going to multiply 1.2 by x and 1.2 times that negative 3. So 1.2 times x is 1.2x, and 1.2 times 3 is 3.6. So it's going to be minus 3.6 equals 10. Is that 10.8? I feel like there's a little thing here. Yeah, 10.8. Now, I don't mind working with decimals, so I will just deal with it and not multiply anything by anything. So what I'm going to do here is solve this by adding 3.6 to both sides. All right, and when I do that, I'm going to get 1.2x equals 14.4. Then to cancel out the multiplication, I'm just going to divide by 1.2. And I get a nice, easy answer, 12. And again, you can replace 12 in for x and verify that this is true by putting in a 12 right here in for x, and then multiplying it out and solving, and you'll get that it's equal to 10.8. So what I want you guys to do at this point is try, you're going to pause the video, try B, D, E, and F. Now, looking at those problems, the hardest one is definitely F. You're probably looking at it and thinking, oh boy, there's there's fractions and variables on both sides. The first thing you should do for B, D, E, and F is cancel out the fractions. Cancel out the fractions by looking at the denominator and finding the least common denominator of those numbers. Then multiply every single term by that, and all of them will cancel out. So you can stop the video at this point and work on those problems, and then before we move on to anything else, we're going to go over all of these answers together as a group.